Hi, I am Brandon Ordonez from ECE31 and today I will be performing our Summative Assessment 3 for our Digital Electronics 2 laboratory.
Brandon's log. So now let us proceed with our experiment. So the instruction is create an ADC application in PIC microcontroller using MCC and MPLAB IDE. So for our application, I have chosen a water system heater. So a water heater is an electrical system which enables the setting and maintaining of temperature released by a water system at a certain temperature. For the experiment, the color of the LED represents the coldness or hotness of the temperature being released, with the red LED at the leftmost side representing the highest temperature of water, and the blue LED at the rightmost part of the arrangement representing the lowest temperature of water released by the water system. The code was made so that the higher the value received by the microcontroller from the potentiometer, the lower the output temperature will be. So now, this is our code. But first, let us open MPLAB XIDE. Build new project. After building project, click MCC. Save. Now, let us open our device resources. From the device resources, go to peripherals, add ADCC. There. After adding ADCC, go to pin module, and at the pin manager, port A0 for the ADCC should be clicked. Since we will use port A0 as our input for our analog to digital converter, which analog value would be received from the potentiometer. Next, for our output, port B to 7. There. After that, go to ADCC, basic mode, FOSC, add clock, there. Maintain these configurations. Next, for your ADCC, let's name it path underscore A0. LED1, LED2, then uncheck the analog boxes for LED1 to LED7 and let the remaining boxes check on the output. There. After that, go to pin module, check your configurations. There. And after that, click generate. After generation is complete, go to projects, sum3, source files, main C. So now let us type our code. I have prepared a copy of our code here. So let's just copy it. There. So for this part, if the received value is higher than 700, LED1 would light up. We have set the LED1 to be the blue LED, and we'll see it later when we place the microcontroller in our circuit. Next, else if the received value is greater than 600, LED2 would light up. Else if greater than 500, LED3 would light up. If greater than 400, LED4. If greater than 300, LED5. If greater than 200, LED6. And if greater than 100, LED7. I have divided the values of the potentiometer into 7 since I used 7 LEDs as our output. We use get single conversion because if we would go to our header files, MCC generated files, and ADCC, you would find here, there, ADCC underscore get single conversion. So back to our main C file. After building our code, after programming our code, click build. After build is successful, go to MPLAB IPE and connect your microcontroller to your PKit 3 and connect your PKit 3 to your personal computer. Once that our PKit is recognized by the computer, click Connect. Since the other options for our MPLAB IPE is already functionable, I have already, this is because I've already accessed advanced mode using password microchip. Make sure that the voltage level is at 3.125 and that power target circuit from PKit 3 is checked. There. After that, browse for your hex file. Sum3, this, default, production. Then after hex file is loaded successfully, click program. After programming is complete, click disconnect. Now we are ready to attach our microcontroller to our breadboard.
So now I will be disconnecting our PKit 3 and our microcontroller from our personal computer. Attach the microcontroller to your breadboard. And now, you should build the circuit. So first, let us attach the VDDs and VSS. After attaching your VDD and your VSS, set your potentiometer, attach its pins. So the second pin would be connected to the input of our ADCC, which is at pin 2. Afterwards, the last pin on the right, the last pin on the right should be connected to the ground. And the leftmost pin to the positive terminal. Afterwards, connect your LEDs. There. After setting your LEDs, connect them to their respective pins. After connecting your LEDs to the microcontroller, lastly, connect the positive and negative terminals of your voltage source. There. Afterwards, connect your power supply to your outlet. There. So we could see that as I turn the knob, the LED that is lit changes. So if I want a hotter temperature output, I would turn the knob to the left. There. And if I want a colder temperature, I would turn the knob of the potentiometer to the right. There. So you can see here that as I turn, the potentiometer from either left to right, the output changes. The output being lit changes, which also reflects that the output temperature also changes. So we could try to see if we could light each LED.
The experiment used a PIC16F18875 microcontroller in order to create a water heating system. Using MPLAB-X IDE's analog to digital converter, the analog value taken from the potentiometer was converted into a digital value using certain conditions as seen from the code. For example, if the value read by the potentiometer is higher than the set value, a certain output would occur. From the experiment, a simple temperature control system was shown with the LEDs representing the hotness or coldness of the temperature at the output of the system.